Hello everybody! Welcome to the first data science course by Machine Learning Grads. Thank you for taking your time today from your busy schedule to learn data science today with us. My name is Adrian Spataru. I'm data scientist at Know Center, and I've been studying data science for several years now. I have also working experience in this industry, and I also have helped numerous companies in their day-to-day problems in data science. I also do consulting and also do partially a bit of research in AI. But I'm not alone. I'm with my co-organizer, Bogdan. So Bogdan, tell us something about yourself.
And together with Adrian, we organize machine learning grads. And Adrian will tell you more about our machine learning meetup.
Thank you, Bogdan. So we will now start. 1 second to press here the screen.
Oh, people said that there was no sound from me.
Okay. So now everything is working. Thank you, chat, for telling us the issue. So, who are we, Machine Learning Grads? Well, Machine Learning Grads is a monthly meetup which bring researchers, data scientists, and students together, where we exchange our experiences in data science and the latest trends in AI. Now, this meetup have been done for every month. However, due to the corona epidemic, no tech events are organized in Austria. And I think that's the same issue in the whole Europe, I would say, for now. So for that reason, we think that learning should not stop. Even in a period of crisis, we should further develop ourselves. And I think in this time period is the best time to really harness new skills. And this led the reason why we're doing this course. We want to bring something back to our community, all the software engineers, all the students, and also junior data scientists who really want to learn data science from the ground up. And we hope through this course that you will have this opportunity to join us with this journey.
And don't worry, if you are not a computer scientist, mathematician, or completely coming from different field of studies, we are starting very slowly. So don't be discouraged. There will be opportunity to everyone to learn data science.
Exactly, Bogdan. So, Bogdan, can you tell us what are we going to do in these 5 weeks?
Of course. So as I told already, we are starting slowly. So today we will look on some basic knowledge in statistics and probability, so we could understand on what all this data science is built. On the second week, we will look into how do we work with data, and we will start with coding. We will learn some essential skills with data processing. Then we will, after we learn how to load and clean data, we will learn how to visualize it and inspect it. On the fourth week, we will look into fundamental algorithm of machine learning, and also do practical exercises so you can learn it on practice. After that, on week 5, we will try to do a real life project. So everybody could say that during this course they finish the project and they will be able to add it to their CV or to their portfolio, which can help with finding a good job or finding a starting position in professional data science life.
Yes, indeed. And there will be, as mentioned, a prize at the end of this. So the top projects will be presented at one of our meetups. And yeah, there's possibilities to actually win something in this. So yeah, as Bogdan said, our goal in the end, to sum it up, is to make you understand how to start and finish a data science project. After that, you're going to have a finished project which you can use in your portfolio. And finally, we hope that you have the skill set necessary to get a junior data science job in your region. So, the agenda for today, as mentioned, is getting the data scientist mindset. And we're going to talk about what are the different elements of data science. One of the things we're going to also look today is essential statistics and probability, which you might already done. Most of it is high school math. But just to be sure that you know this, we're going to do a good refresher on this subject. And it will be also fun. And finally, we talk about what I think is one of the most important lessons as a data scientist is the importance of data and data science. We will explore what data really means and how we use data from a theoretical perspective to solve different data science problems. But before we do this, I ask all of you to get pen and paper, because we will do practical exercises, and I want you look around. We wait a bit, get your pen and paper, because we're gonna test your knowledge, and we're gonna also have quizzes where you can get scores and points, which will be in the end used for also a prize. So please take your time. When I say take your time, I mean now.
No. Yeah, look for that pen and paper. And in meantime, we already have a first question in the chat about a project. Can a project be done in team? I think yes, Adrian. What do you say?
Yes, I definitely see working in team is totally fine. Just tell us who you did it with. Don't make a team project and say, "Oh, I did it alone." If you did it as team, it's totally fine. But please give credit where it's due. Second thing I want you to do now is go to the following link. Open a new tab on your computer, or open it in your phone, and enter to ahaslides.com/mlgrats. The reason is that you can ask us questions there. That's the first thing you can do. But secondly, you can participate in our quizzes, where where you can get points to get, which gives you a chance to win prizes in this course. So we'll give you a second to find your pen and paper, and please log in to this page.
Yeah. Because we want to make this as much interactive as possible, so we don't want you to feel that you are watching a recording. We want you to interact with us, put your questions, write something in the chat, and we will try to questions you have.
Yes, indeed. Yes, indeed. Okay, so to see if this works, there should be a poll now starting, and you can now vote. So I want to see you guys. How excited are you for this course? Please tell us on AHA Slides how excited you are. Okay, we've got 80 people already logged in. That's great. And it seems most people are very excited. So that's really great to see. Okay, we're gonna give you several more minutes, several more seconds, and then we're gonna actually start the course. So,
Adrian, can you put a link in the chat so for people that missed the previous slide?
Oh, sure. Yes, I will put it right now. I will try to write it now. AHA Slides. So the link should be visible on the screen. It's on the top. It's told here to join ahaslides.com/mlgrads, but I'm gonna write it now in the chat. Okay. So we're almost there. How many people do we have now? I think 88, 87. Okay. Okay.
So yeah,
very good. So I think we're ready now to start, Bogdan. What do you think? Should we start?
Yes, I think, and we can, if somebody will join later, we will keep the link in chat. We will remind when the first quiz will start that people can still join us, so don't worry. And yeah, let's proceed with this lecture or course or training. How would you like to call it better?
So one more last thing to mention is that you can ask questions on any time on AHA Slides, and in the end we will have a Q&A session, and we're gonna answer all your questions. So there should be a button in AHA Slides written there, ask question. You can ask your questions there. So that's it. Don't forget to ask your questions, because I expect a lot of them. So we cannot answer everything on the chat. So we would kindly ask you to use AHA Slides to ask your questions. Okay, so that's it. I would say let's start. So Bogdan, can you tell us what do we see in this image?
Yeah, so as you can see now in the world, data science, artificial intelligence, and machine learning, these words, they occur everywhere. And everything now is data connected. And here we can see some of the industries where the data science is the most used. So first that comes to the mind is automation, and especially self-driving cars. It looks futuristic and everybody is excited about it, but there's so much more that you can do with data science. As I said, I'm working in Kleine Zeitung, so I'm working in media and doing data science there, and you can be data scientist in healthcare, especially now in such a hard time of pandemics. Maybe if you become data scientist in that domain, we won't have so many pandemics in future. And in general, you can find implementations of data science everywhere. So everywhere where there is data, there is a job for a data scientist. And to understand what is data science, first we need to understand relation between the words artificial intelligence, machine learning, deep learning, and data science. And this tweet perfectly summarizes relation between artificial intelligence and machine learning. Artificial intelligence is like umbrella topic. It's so general that it's really hard to describe it, and it's used often by salespeople to sales artificial intelligence solutions. But what is actually is implemented is machine learning. So if you put it on a perspective, we can say that artificial intelligence is all techniques that enable machines to mimic human behavior. And machine learning is a subset of those techniques, which led those algorithms or solutions to learn based on experience. And deep learning is a subset of machine learning, which is based on neural networks. And data science deals with all of these three topics and with much more, because not data scientists not only implement those artificial intelligence solutions, but also they have to understand the computer science, so they implement not just in theory that solution, but also in a way that it can be used in business, that it can bring some value to the company where you're working. And moreover, you need to understand the domain where you're working, because you need to understand that you cannot just blindly look on any data and do some analysis on it. You need to understand where it's coming from, and what is why. A lot of reasoning you need to understand before you actually start doing some machine learning and any other mathematics. So you need to know mathematics, computer science, and be domain expert. And today we will focus on mathematics part of this knowledge of data science. We start with statistics fundamentals, and then we will get to probabilities. So Adrian, please introduce us to the most important parts of statistics.
Thank you, Bogdan. Thank you, Bogdan. And statistics, like maybe you were scared from school. So let's bring your time back from school. So let's say, like Bogdan, these were my grades, I think, in high school. For the most part, I was an average student here and there. Now, my grades were 3.315. If I would calculate the average or the mean, to calculate that, I would sum my grades together, 3 plus 3 plus 1 plus 5, and divide them by the number of grades I have. So this would give me the average grade I would have at high school. So again, that's the sum of all data points you would have divided by the number of data points. I think everybody did this in their high school times, or maybe even university time, to really calculate their grades. Another example would be the median. So the median is a bit more different. So here's some grades I would have. And the median would be the value in the middle of that set of values. So in this case, we can see the 2 is in the middle of the set of grades we would have. And in case we would, in case, however, we would have 2 values in the middle. So in this case, we can see the set of numbers is even. The median would be the 2 values closest in the middle. So that would be 2 and 3. And we would take the average of those 2 values. Therefore, my median grade would be 2.5. Now, why are we talking about mean and medians? Why are these important? Well, let's just give you an example. So what you see here is the distribution of family wealth in the US in 2016. The reason we took 2016 is because we can fit it in the image. 2020 would be very hard to actually plot it. So
Adrian,
yes.
Please remove the mouse pointer from the middle of the screen.
Okay, thank you for calling that out. So here we see the distribution of the family wealth, where on the y-axis would be the wealth of the people, and on the x-axis would be the population who has that. And what we can see is that that most people are not earning a lot, but depending how you see it. So if you would ask the question, how much does the average family in the US own in wealth, then that would be different than the median. What do you think, Bogdan? What do you think the average person has in as wealth?
Yeah, well, that's we can see now on this graph that the average is much higher, because if I make 0 and you make 10 millions, in average both of us make 5 million, but that's very far from reality, and that's where it comes where we need to understand the difference between average and median, because sometimes average doesn't describe the real situation, and technique of swapping between median and average is often used by politicians and other interested parties that want to manipulate people opinion, and they report the average values instead of the median. So here on the graph you could see that, like, if you take on average, it seems that everybody is doing really well, but if you look on median, we can see that most of the people don't do that well. They don't have that much money as the average number reports.
Yes, indeed. And this phenomenon we can see also in different places. Instagram, for example, is very similar. So what we see here is the distribution of Instagram likes, and a small amount of people get the most number of likes. So if we would ask what is the median and what is the mean number of likes, we would see that in median, a person would get 23 likes, and in average, mean, a person would get 325 likes. So I don't know about you, Bogdan, but I never had more than 40 likes in my life.
Yeah, same for me. I'm far from being an Instagram influencer.
Yes, so that's why it's very distinct. We need to see the value of mean and median, because that has very lot of influential power in the world. So we've shown previously with the Instagram this curve here, this bell curve, also known as the Gaussian distribution. And the reason we care about this a lot is because a lot of phenomena around the world follow such distribution. Such examples would be the height distribution among men, where the average, as we can see here, the average person has a height of 183, and it follows a Gaussian distribution. Another example will be the volume of milk produced by cows. So in average, a cow produces around 5 liters of milk, but there's some variations here and there. And finally, I think what most people are interested is IQ. So IQ also follows a Gaussian distribution. Now, what we see here is also some numbers here, and this is an interesting topic, and that is standard deviation. Now, first, before I explain what standard deviation is, I want to explain you some terms. So standard deviation is the squared difference between every data point we have, between the data point and the mean. And the mean is what we saw before. This is just how you would write it mathematically correct. But this is the same as what we saw before. The sum of every data point we have divided by the number of data points. And this standard deviation has some interesting properties we would care about. So if you look at this following plot, we will see here the standard deviation, so the effect of the standard deviation on the population. So if I have a standard deviation of 0, that means I am the most average person in the world. So if my IQ would be around exactly in the middle of this plot, I'm the most average person. However, if I'm here on the right, where one standard deviation is defined, so this region, then I am within the 34% of people who are smarter than the average of average person. Finally, if I would be 2 standard deviation over the average, then I would be 34% plus the 13% here, therefore being 47% smarter than the average person. Make me almost a genius. So how can we use this information to ask some questions? One of the most typical questions would be, how smart are you? And let's assume that my IQ would be 100. Well, in that case, that is very simple. Your IQ is average, therefore you're smarter than 50% of people. Why? Because the average IQ is 100. We can see it here. So why I am smarter than 50% of people? Because you exactly here in the middle, you're smarter than everyone else on the left side. Okay. But I think all of you here are smarter than that. I assume anyone who wants to become a data scientist already is smarter than 100, Bogdan. Do you agree?
Of course. I think they are like in the 2%.
Yeah, I think also. So let's start with a small number. Let's say my IQ is 110. So how would we calculate this? Now, this is not easy, but we have something called the z-score, which can actually help us answer this question. So this is the formula of the z-score. So the z-score is defined by x, which is in our case 110. What is your IQ? Minus the average divided by standard deviation. So x would be somewhere here. The average, as we all know, is 100. So that would be the line in the middle. And the standard deviation is this region around here. And in our case, this is 15. So standard deviation means the standard deviation covers 68% of the population from both sides. So if we have all these three numbers, we can calculate the z-score. And this will give us, if we just put the numbers in the formula, we would get the value 6.66. Now, what's the 6.66? What can I do with this? Okay, how does it tell me I'm smarter? Wait, there's one more step. There's something called the z-score table. So in the table, you would get a probability of how smart you are. So in our case, the table you can find on Google, you can find in your statistics books. It's very easily available. So in our case, our z value is 6.66. So if you're going to search it in the table, we will find it exactly here. So we have this value, 0.2454. Okay, Adrian, thank you for this number. What does it mean? Well, I can help you out with that. So if your Q is 110, then you are smarter than 24% than the average person. So I repeat that, if you have an IQ of 110, then you are 24% smarter than the average person, which has the IQ of 100. In other words, you're smarter than 74% of the people. Why? Because if the average person is smarter than 50% of the people, added with the 24, then you're 74% smarter than the people. And I think that's quite low, because I definitely think our people from our course definitely have like around 130. What do you think, Bogdan?
Yes, of course. If if they joined us, it means that they already have high IQ. Until the end of the course, they will even move more to the right on the IQ graph.
I agree. So enough talking, and let's do an exercise. So everybody get your pen and paper and log into AHA Slides if you haven't done it yet.
So if you joined us later, go to ahaslides.com/mlgrads. You can see it in the chat, and you will be able to participate in a quiz.
I'm gonna post it just in case one more time on the chat, just so if they haven't seen it yet. Okay, so we are doing an exercise to test your knowledge what we did today. So we have the distribution of all the height of the dog breeds. So how high? What is the height of a dog? And in average, a dog height is 75 centimeters with a standard deviation of 25. So we're gonna do a quiz now. So everybody join in AHA Slides, and we're gonna test. We're gonna give you the homework or the quiz to calculate the z-score for different dogs.
And we are doing it now, so it's not a homework, it's more like exercise now.
Exactly. We've got 25 people, 26, 28. Come on, guys. So I strongly recommend you should join, because there is prize to win. Not today, however, but for the people who through all of the course get the highest score, there will be a prize for you guys. So join the competition. We've got 65 people, but we have 101 people active on AHA Slides. So we need to keep up the pace, guys.
Yeah, I think people are just looking for the best smiley face to represent them. It's such a hard choice, but yeah, number is rising, and soon we will be able to start.
I mean, Bogdan, is like the emoji is almost there. If you got the correct emoji, then you almost win all the time, right, Bogdan?
Exactly. It's like, get that scientist emoji.
Okay, so we've got 85. I'm gonna wait several seconds, and then we're gonna start. Now I know there's a slight delay in the stream, so that's why I'm waiting for people to join. But yeah, we cannot wait for everyone. We have to start sometime. So okay,
it's
we've got
just like real life. If you are too late, you are out.
Correct. Okay, I think that's it. We're gonna start right now. Okay, so look on your phones or your tablet, because there's going to be a description. But what you're going to do now is calculate the z-score of a Dachshund. So a Dachshund has an average height of 25 centimeters. So because I'm nice to you, I'm going to give you some tips for the first quiz. 25 is your X. The formula should be described there. You should have the formula there on the description. The mean is 75. Standard deviation is, I think, was 25. Just plug those numbers and you should be fine. For that, I'm going to put some focus music. And time's up. Now I know there might be a small delay, but most people managed to actually answer, and correctly. Amazing. So let's see what was the solution. So the answer was X, which was 25, minus 75 divided by 25, giving you minus 2. So if you managed to get that answer, good job. Now we helped you now, but let's see if you can actually do it by yourself. So, quiz time again. Okay. So this one is a different dog. I think now you can actually calculate it. So we're gonna start it right now. Don't forget, look at your phones. There should be all the numbers should be all there in the description. So good luck.
this time we have a great day.
Three, 2, 1, and time's up. Okay, let's see the numbers. Wow, excellent. You're getting better now, guys. Okay, final one. This time we're doing it with the Gold Retriever, one of my favorite dogs. So let's see how you're doing this time. And time's up. Last second votes. Okay, perfect. So, great job everybody who managed to put their correct answers. And as mentioned, there are prizes to win in the end of the whole workshop. So for now, this is the leaderboard. Track your name. Don't forget to use the same name next time. And yeah, good job, Max. Second place by Lucas. Third place UQ, Oliver, Dr. Evil, JF, and Elder123. This is a close one. And these are really smart people, Bogdan. They're really good.
Exactly.
Yeah, they are all of these participants, I think, have the great chance to become true data scientists at this pace.
Someday they will teach us.
Someday they will teach us. But for now, something totally different. Let's talk about coin flips.
Yeah.
So what I have here is a coin. And I want you to predict if it's heads or tails. So, everybody, look at your phones or your PC and vote if this is going to be heads or tails. Okay, I'm going to wait 10 more seconds and we're going to flip the coin. You won't get points, but you will definitely get street credits for this. And street credits has a big say in data science. Do you agree, Bogdan?
Of course, it's mostly based on street credit.
Okay, so everybody voted. Now I'm gonna flip the coin. And let's see. Okay, let's see what the people voted. So I see almost half the people voted tails. And the correct answer is heads. Congrats everybody who voted the heads. Even though a slight minority, they actually got the answer right. Interesting. I see great future in them.
Yes, but...
Okay, so why are we talking about coin flips? Well, Bogdan, can you tell us about this? Why are we talking about the subject?
Of course, because we are moving from statistics to probability. And if we are talking in scientific terms, what Adrian just did was an experiment. And the fact that he had heads or tails was outcome. And the probability is a measurement, it's a numerical description of how likely an event is to occur. So, and probability is usually, it's always between 0 and 1, or if you count in percent, it's between 0% and 100%, where 0 indicates that the event is impossible, and 1 indicates that it's certain, so it's for sure happens. And we can look here we can see the probability formula of the formula of probability, which is very simple. It's a number of favorable outcomes to the total number of possible outcomes. So in case of coin, it's very easy. We have two possible outcomes, head and tails, and our favorable outcome is tails. So it's 1 to 2. And there is a lot of examples. We will talk about a lot of probability is very well connected with gambling. So a lot of examples will include casinos, cards, dices, roulettes, and other gambling things. So here we can see example dices. So dice has 6 sides, which are numbered from 1 to 6. And if we want to look at the probability of even number, we calculate all even numbers. There is 3 even numbers on the dice and divide by total possible outcomes, which is 6. So it is 3 to 6, which is 1 to 2. Now let's look on a card. So let's imagine you have a playing deck which has 52 cards. We don't use jokers. And what's the probability of getting ace from the deck of cards? Well, it's it's a 4 to 52 because we have 4 aces and 52 cards. So probability is 4 divided by 52.
Yes. So as Bogdan said, if you're good in data science, you might be also good in gambling, right, Bogdan? What do you think about it?
Well, you might be, but not always. Not always. So yeah, let's start with simple questions. So if to see like how you understand the probability, if you can count simple probability tasks.
Okay, so I think we can start now the quiz. So the quiz are starting right now.
Yeah, probability of getting hearts. Just to say easy tip, there is 4 different options for different
suits.
Suits, exactly.
And time's up. Okay. So amazingly, almost everybody got it right. Great job. So in case you didn't manage to write the correct answer, the answer is the following. 52 possible outcomes, because we have a deck of 52 cards without joker. We have 13 desired outcomes. Why? These are all the hearts from ace to king. And we just divide those two numbers. So 13 divided by 52, therefore a probability of 25%. So 1/4. Okay, let's go with something more tricky. Okay, so this was a bit more easy. Now let's test a bit more your skills. Starting in 3, 2, 1, now.
So number cards from 2 to 5, from 2 to 10. So now you know that there is in total 13 cards from 2 to 10, and we are looking from probability of getting from 2 to 10.
Time's up. So this was interesting, a very interesting outcome. We can see here that some people think it's 69%, some people think 50%, some people think 76.9%. Interesting. So this is where people actually got confused.
Yeah,
So
yeah, maybe not everybody is such a gambler as we are. Not everybody had a deck of cards, but same in life. When you come to the project, you don't know the data. Sometimes you need to adapt fast, learn new stuff on the fly.
I agree. But in case you didn't got the answer right, let's break down the answer. So again, we have 52 possible outcomes, right? A normal deck of cards. We have 36 desired outcomes. Why 36? Well, first of all, we only said number. Ace is not a number, okay? So you have 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, these are 9 possible outcomes times 4 because you have 4 suits, and therefore giving you the probability of 69%. Okay. So the leaderboard has changed a bit. I see Dr. Evil, Lucas, Max, Robert, Oliver, and Libby all in the top 6 places. So yeah, good job, guys. Okay, now further on, let's go. So Bogdan, can you tell us about the addition rule?
Of course, I can't tell you about that. So what now we just looked on the events on probability of one event happening. But life is not simple. There's a lot of events happening simultaneously. And what if we want to calculate a probability of 2 events happening, or one of 2 possible events happening? And here, for the addition rule, we have So for those cases, we have addition rule when we want to calculate probability of 2 events that are not mutually exclusive. So what it means that it can happen that event A happens, or event B happens, or both of them happens. That's what it means that they are not mutually exclusive. So the example would be a probability of getting ace or any red card. So we would calculate probability of getting ace as add probability of getting red card and subtract probability of getting red ace. Why we need to subtract it? Because probability of getting red ace is already counted in probability of getting ace or getting red card. So if we don't subtract it, we will get probability which is higher than 1, and that's why we need to put it into consideration. So the answer to this question would be as follows. So we have a probability of getting ace, which is 4 divided by 52. Then probability of getting red card, which is 26 divided by 52. And we need to subtract probability of getting red ace, which is 2 divided by 52. And the answer is 28 divided by 52, which is roughly 52% if we transfer it into a percentile. So that's where mutual events that are not mutually exclusive. There's different types of events, and one of the good example of other events are independent events. And independent events are events that have no connection to each other. In other terms, they don't affect probability of each other. So, for example, when you flip 10,000 coins, it doesn't matter. Every coin has its own probability to have head and tails, and they don't affect each other. Same with dices. When you roll multiple dices, dices don't affect each other. And it can go much further. For example, when you see black cat, it doesn't affect how you write your exam. So it's independent probabilities.
What?
And
I thought when I thought I failed my exam because of the cat. I mean, I've learned and I still failed, but only because of the cat, Bogdan.
well, maybe there was some other dependent events that lead to you failing exam. And we will talk about dependent events right after multiplication rule. So when you want to calculate the probability of getting two independent events happening, you need to multiply probability of those two independent events. So if I want to flip two coins and see what will be a probability, I will of getting two heads, I will multiply 1 divided by 2 on 1 divided by 2. And let's look on other example with dices. So as I told, we are talking about probability and gambling are very connected to each other. So if you play dices, you would know there is such a thing called a snake eyes. It's when you roll two dices and you get two ones, so it looks like eyes. And so to calculate it, it's very easy. We take probability of getting 1 on the first die, which is 1 divided by 6, and multiply it on the probability of getting 1 on second dice, and it's 1 divided by 6, multiply 1 divided by 6, which is 1 to 36. And now we are coming to dependent events, and that's events that depend on each other. Therefore, they influence the probability of each other. So, Adrian, maybe you failed your exam because you saw a black cat, but maybe because you were drinking all night before your exam. And
Oh,
that's
that's true. Oh, that's true. Oh, yeah, I forgot about that. Yes, you're right.
That's why you need to have a very good understanding what is dependent event and what is independent. So, for example, dependent event is learning data science and getting well-paid job. Or if you are in a country that is under the pandemic and you are breaking quarantine, you are probably getting the virus. So that's very dependent event. And same, if you don't buy lottery tickets, you don't win the lottery. So that's also dependent events.
Indeed, indeed.
And dependent events are very important in data science because a lot of events in our lives lead to other events. Same in data, something cause another, and one part our job is to find the reason why some events happened. And here we have the conditional probability formula, which help us to calculate probability of event A occurring given that event B has already happened. So something happened, and now we want to calculate the probability of other event happening. And the formula is very simple. It's just the probability of A and B happening divided on probability of B happening. So let's look on example. So let's resume that event A is probability of having high paid job, and probability of event B is being a data scientist. And let's presume that probability of being data scientist is 1 in 30. Then probability of A and B would be probability of being data scientist and having high paid job, and let's presume it's 1 in 50. And then we want to find the probability of data scientist having a high paid job using a formula of conditional probability. Therefore, we just put the given numbers in the formula. So we divide 150 by 1 divided by 50, divide by 1 divided on 30. And in the result, we get 3 to 5, meaning 3 out of 5 data scientists have high paid job. So Adrian, do you belong to these 3 people out of 5?
Yes, I do. And I think also most of our future data scientists from this course will also be in this 3 out of 5 people.
Exactly. So there is 2 of us, and somebody from audience will become third.
Yes, indeed. So now we've learned a bit about probability, and I think now it's a great time to do a quiz again. And
yes, so people don't fall asleep listening to us.
correct. So get your pen and paper ready, and as you can see in the background image, it's gonna be our dice. So I would say if you're good in gambling, you could be quite good also in data science to a certain extent. So I think we can start the quiz any moment now. So yeah, the quiz will start any second now. And good luck. So please read the description in your phone. There will be some hints over there. And it's all about trying 2 dice. Now, if in case you forgot the probability of 1 dice rolling a number of certain value, it's 1 to 6. So take that into account if you need it. Okay, perfect. Most people actually got the answer right. So, in case for those who actually got the answer wrong, let's go over the answer. Oh, actually, we cannot go over the answer.
Because we have next question.
Next question, indeed. So, round 2. Now, this one is a bit harder. This is the probability of getting a 7. So, you have to take all the permutation in counts. So, a desired outcome could be 6 and 1 and 1 and 6. So you have to take both sides of the dice.
3 and 4, 2 and 5.
Exactly.
Don't forget about those.
Exactly. Now, if you want one more hint, there are a total 36 possible outcomes in total. So maybe that will help you. Okay, good luck. Time's up. Okay, let's see how you did, guys. Oh, and the majority got it correct again.
Wow. That was very tough question. It's not easy.
Yes, indeed, especially with the time frame they had. I think these people will definitely become the best data scientists, better than we expect. I think they would need to teach us next time.
Yeah.
So let's check the leaderboard. Now, the leaderboard has switched a bit. Robert is first place. Libby, Oliver, Lucas, Max, Oak, Q, and Dr. Evil are leading the leaderboard. Okay. Ha! So give me a second for this one, because we have something special for you.
Yeah, we know that learning so much is tiring. That's why we bring you little
A surprise.
game.
But before we do
Little-
this, before we actually show you the little surprise we have, some of you saw a little frame there for a second. Let's talk about the dice probability. And here we can see,
Of course.
here you can see in the image the Gaussian distribution of the dice. So a lot of phenomena actually follow the Gaussian distribution. And in this case, we can see there are 1, 2, 3, 4, 5, 6, 7 times 2, so 14 possible options to get the 7. So I saw actually a comment in Twitch, Robert Bauer, but aren't there 12 out of 36 options because dices can have 1 and 6 and 6 and 1? That's true, but they're not 12, they're 14. Okay, so let's open the surprise. Welcome to the only online show, Win a Car! The only show where you can actually win a virtual car in the comfort of your home. For the best price, you can win the latest Tesla with all the premium accessories. However, you can also win beer. As we say here in Austria, in Graz, a kiste punti. We can actually win this in the other rooms. Now, what is the game? Well, the game is quite simple. Choose a room, and one of the items behind the door is the car. But if you don't find the car, you unfortunately have to go with beer home. So one of the rooms has the car, the other two have the beer. So for now, it's time you to choose, and maybe you can win a car.
Or a beer. So
or
that's
a beer.
a win-win situation. You're not gonna lose in this game because you are the best audience. We don't want you to lose anything.
Yes, indeed. And you know, Bogdan, I'd be happy with the beer too, especially Punti Gamma. You know, who would say no to Punti Gamma, right, Bogdan?
Yeah, Punta Gamer, if you are watching us, there's contact details in the bottom.
Yes, please contact us. We gladly we gladly would take you as a sponsor for our next meetup. Okay, so the vote is going on.
What do you think? People are more excited about car or about beer?
Well, for me, I'm equally excited for both. So I think if they're also data scientists, they're happy for both of them. What do you think, Bogdan?
Yeah. Especially, well, the car is always, with the car you can drive through the car and get that kiste of Punti.
Yeah, I agree, definitely. Okay, so I guess we will now lock in the answers. So it seems there's a clear majority for door yellow. So I guess it's time to open the door.
Yes. We go with majority. Sorry, everybody who voted for other doors, but democracy is democracy. Majority wins.
However, before I open door yellow, the yellow door, behind, I will open one door where the beer is located. So I will open one of the doors, which in this case is door red. And in this door red, you will find the beer. So I'm gonna ask you right now, people. Do you still want to keep the door yellow? Or do you want to switch and open the blue door? So, before I opened you one of the doors where the beer was. One door still has the car. Maybe it's the one you selected, the yellow. However, maybe it's in the blue one. So are you going to keep the yellow door or are you going to switch? Okay. I think that's enough time. There's a clear majority that people want to switch. Now, I'm impressed, Bogdan. These people actually are data scientists.
Exactly. You see?
Okay, so let's see what's behind the blue door. And you have won! You have won the Tesla! Impressive. These people are amazing. For those who wanted to keep the door, you win a beer. So it's not so bad. You can enjoy yourself, at least drink your sorrows with a Puntigama.
But you have to drink it alone because stay at home. There is quarantine.
Yes, please stay safe. Please actually listen what the WHO and your government says. Please keep safe and healthy. So this wasn't purely random. There's some math behind this, some statistics. So let's simplify the problem first. So here we have two doors. Now, behind one of the doors, you will find the beer, and in another door, you will find the car. So if I would tell you to choose one of the doors, there would be a 50-50 chance that you would actually get the car. However, in our case, it was a bit more different. So here we had three doors, where two of the doors had the beer and one of the door had the car, each with a 33, so a third. That means 33.3% chance winning a car. So if I would tell you choose a door in the beginning, you would have a chance, a 66.6% chance to actually getting the beer, but only a 33.3% chance to actually getting the car. So you're more likely to win the beer when you would select the door. But there was a small twist, right? A small variation. I showed you one open door, right? So let's go for an example. So I would select the red door first. Now, the red door, we selected, but before opening the red door, I would open one of the doors where a beer would be located. So in this case, let's say the yellow door. Now, the probability is not 50-50 that you're getting the car. We know in the beginning that the chance of you getting the car is a third. So what actually happens now is that if you keep, you get only a third probability of getting car. But if you switch, your probability increases to 66.6%. Why? Well, let's go into the math. So as mentioned in the beginning, you get a 2 out of 3 of the doors have the beer, the Puntigama. So that means you get 66% possibility of actually winning the beer. And if you would select if you would select the door which would have the car, you would only have a third chance to getting it. So now becomes this example of keeping switch. I would show you one of the doors where the beer was located. If you would keep the door, given that I showed you one of the doors with the beer, the probability of getting the car by keeping your selection is still a third, right? Because in the beginning we chose a third. However, if I show you where one of the Puntigama beer was, switching actually increases your probability to 66% of winning the car. So if you didn't understand the example, let's simplify it with a bigger example. So here we have 100 doors. I don't know how many doors here. And we will do the same game. In all of the doors, there will be Puntigama, the beer, except one door where would be the car. Now, I would ask you, select the door. You would select the door, and before opening that door, I will open all other doors where the beer was located. And in this case, it's kind of obvious that you likely chose the room with the beer. So it makes sense to always switch to get the car. Okay. Oops. Here's some slides I have to skip. I will play some music until I reach... We have technical issues here.
Well, Maybe we can take, while you're switching, take the questions from the chat. So the first question was deadline for the final project. And
so the deadline of the project, so we will define the deadline after the last week. There we actually gonna define what projects you're gonna work on. Okay, so we're back, guys.
Okay.
Thank you for waiting. So
one question per one technical issue.
Exactly. Hopefully we can keep that in that pace. So let's do another example. Here we have a sack of marbles. So in this sack we have 10 red marbles and 5 blue marbles. And I would ask you, what is the probability of taking one marble out and this marble being red? In this case, it would be quite simple. Because we have 10, it would be 66.6%. Why? Well, we have in total 50 marbles, 10 red and 5 blue, and we have 10 desired outcomes, which are 10 marbles. Okay, but let's make it more different. What if I would take two red marbles? So first, I would put my hand in the sack, take one marble out, and it should be red, and I go again and take another one out. So in this case, the probability is a bit more different. For the first one, it's still the same. It is 10 divided by 15. However, for the second one, it's 9 divided by 14. So let's see how this actually looks like. So in the beginning, we have 15 marbles, we have 10 desired outcomes. So therefore, 10 divided by 15. And this is times 9 divided by 14, because the one of the red marbles is actually taken out. Therefore, the total marbles in the sack is 14, and we only have 9 possible outcomes left. So we won't let you so easily. We want to do another quiz. So everybody join in, because we're gonna want to test your knowledge with what you've learned.
Yes, because what we want to do, we want to give you this ability to think in probabilities, so you're not confused when it's coming to serious things. So maybe you won't use it directly, but this feeling for the numbers you get will help you to understand more complex things.
Correct. So for those who join a bit later, if you want to participate in the quiz, you can press on the link which I wrote on the chat. However, you can see here on the top, it's ahaslides.com/mlgrats. So you can join the quiz. We will wait a bit, and we're gonna start any second now. Okay, I think we're ready. If so, I guess let's start your knowledge in probability. So again, a very short technical break, but there won't be need for questions. Okay, now we're ready. So let's start the quiz. So we're gonna do the same example with the bolts. What is the probability of taking 3 red marbles out of the sack? So again, we have 10 red marbles and 5 blue marbles. In total, we have 15. Okay, good luck. Okay. Time's up. And the majority got it right again. Excellent. Really good job, guys. Really good job. Proud of you. Okay. So in case I saw some of people got the wrong answer wrong, don't worry. Don't worry if you didn't understand. So we're gonna present the answer to you now. So for the first marble, the probability was 10 divided by 15 because we had 10 red marbles and in total 15 marbles. For the second red marble, it's 9 divided by 40 because we took one marble out. And then for the third one, it's 8 divided by 13 because 2 marbles were previously taken out. So the correct answer would be multiplying all these probabilities together and therefore resulting a probability of 26.37%. Okay. Now for another quiz, a bit more trickier. I think this time everybody should get the correct answer. I'm really confident in you people, you future data scientists. I really think you can do this. Now this will take you some more math, so please get your pen and paper ready. Maybe take your calculator. So yeah, we will start in 3, 2, 1, now.
And just to address the latest question in the chat, it's independent events, but we take into consideration that amount of marble decreased. That's why we need to decrease the amount of all possible outcomes, because there is not a 15 but 14 marbles on the second turn.
Correct. Time's up. And this time this went well, very good. Now this time most people actually got the correct answer. However, I see based on the numbers of answers, I think not everybody was finished calculating. So next time, try to be a bit more faster. In data science projects are also constrained by time. So speed is very important.
Deadline is always there.
Deadline is always there. You said it nicely, Bogdan. Okay. So let's check the leaderboard. Robert actually increasing his lead by a lot, followed by Max, Lucas, Destroyer, Oliver, Uke, and again Dr. Evil. Okay.
Yeah.
So we will go to a break. But before we go to a break, we have one more quiz. Bogdan, please take the lead.
Of course. So back to the gambling, and now we are in casino and we are playing a roulette. Here we have a standard version of roulette where we have 36 numbers and 1 0. So we have 18 red numbers and 18 black numbers, and 0 doesn't have number, 0 is green. And how the game of roulette is played is that every round the roulette is spinning and the ball will fall in one of the numbers. And we are following the strategy that we are betting always on one color and always increasing our bet. I think everybody saw this strategy in those guides how to beat the casino. And last 10 games it was last 10 games, the ball always landed on a black number. And what we want to do is now to calculate the probability of getting a red number. So what can you tell me what would be the probability of getting red number?
So the quiz will start right now, but because this will take a bit time to figure out what are the possible outcomes, everything, all the math will maybe take you a bit time. We will give you for this one a bit more time before we actually start the quiz. The quiz
And
will be only.
Adrian, before we will go to the breaks, we will have to address the dices again because there is an active discussion in the chat happening.
I see. I see. Okay, we will do that. Then we will do maybe a very short Q&A session, maybe for the most burning questions.
Yeah.
But for now, let's focus on roulette. We will talk about dices in a second. So please now start calculating. We will give you some hints. As you can see here, there are, I think, Bogdan, can you tell us more about the probability of getting red, maybe? How many possible outcomes are there? Maybe give a people a tip.
There is 18 possible outcomes to get red. And in total, there is 36 numbers and 1 0. Don't forget the 0.
Yes, don't forget the 0, indeed. So I will give you one more tip. Think about it. Is this independent or dependent situation? Okay, so I will start now the timer now for 1 minute, and then afterwards I will start the quiz so you can put your answer in.
Yes, so the lectures will be saved, so we can always watch complete stream again. And so don't worry if you join later.
Yes, don't worry.
Following classes, we will save all the streams.
Yes, correct. So you can find, they will be on YouTube and it will be also on Twitch. So don't worry about it. The only disadvantage just joining late is that you cannot participate in the quizzes where you can rack up points for actually winning prizes. But if you're here only for learning, that's great. You will never lose the possibility to learn at home later. So that said, I think we are. I think they had enough time to calculate.
Yeah,
Let's start the quiz to put your answer in. Everybody start joining and be ready to lock in your results. One more short technical break of 20 seconds before I started the quiz. But get you ready. Be very ready on your phone. There will be only 20 seconds to actually put your answer. So please be ready and look on your phones.
Yeah, and if you miss your question, don't worry. You can always ask them on AHA slide. There will be a Q&A at the end, and you always can contact us, through mail, LinkedIn, send us any questions related to data science.
Indeed. So for now, let's focus on the roulette and let's see what people predicted. So look at your phones and put in your numbers. And time's up. Let's see how you did, guys. And majority actually got it quite right, 48.6%. For those who got 10%, his thing is that this is a independent event, right, Bogdan?
Yes, so that's so all the articles you saw on internet about how to beat a roulette is a lie. The probability does not change. Doesn't matter how many black outcome were before. It will be still 48%. And now, why not 50? Because there is zero. Zero shifts the probability to 48 from 50. So that's why casinos always win, because the probability between red and black is not 50%, it's 48.6, because zero doesn't have color.
Indeed, indeed.
And on this note, we're going on a break.
But before that, let's check the leaderboard one more time before we go to the break.
Of course.
Yeah, so Robert, followed by Max, followed by Lucas, Destroyer, Oliver, Dr. Evil, and we've got a new person in the leaderboard, David. Okay, so I think before you said there was some drama regarding...
No, not drama. I'm really happy for the community, because we got people answering other people questions. So I think now the topic of the dice is closed. Well, you can go back to the slide with the distribution, so we can see all possibilities of getting 7.
Okay, so before we go to break, so if the answer was clarified, is there any questions we should deal? Was there anything else, Bogdan?
No, it seems everything is fine now. So let's go on a break. Let's have 10 minutes break. So everybody get a fresh cup of water, go to the flex of stretch a little bit, not to sit so much, and we will see you in 10 minutes.
Yes, indeed. We will see you in around 10 minutes. I will put 11 minutes just in case for myself.
Okay.
everybody. So I hope you had a great break. You're feeling refreshed. Your brain is ready to consume more information. And I think this part of our workshop is definitely very important. For now, we did some, probability refreshers, get ourselves in the right mindset. But now it's really to time to where we shine, where we talk about data. And I think, Bogdan, this is a really interesting topic. So,
Yeah.
um, I guess we can start any moment now. I need to set this up. Yep, I think we can start. So, Bogdan, I like data a lot. Can you tell me what is data?
Of course. Well, the data is the most important part of data science because without data science is just science, which is boring, everybody knows. And with data, we have data science. And data is a collection of facts such as numbers, words, measurements, observation, or just description of things. So data can be basically everything that describes something is data. But well, we can, in order to work with this data, we need to categorize it in some meaningful ways, because we cannot put numbers and text all together. It needs to make sense. So there is different data types, and on a highest level, there is two data types: qualitative and quantitative. And qualitative is from the word quality, so that's the data that describes some quality. For example, excellent data science course is one example. Big soda cup is also example. Or think data like that define like sex, which is male, female, or others. This is the type of qualitative data. On the other side, we have quantitative data, the data that we get from measurement and counting. For example, if you would have to rate the course, it can be 10 out of 10. If we measure the amount, the liquid possible in soda cup, it can be 500 millimeters. We can measure temperature, we can measure amount of use. So everything that we measure and count is quantitative, because it's from word quantity. And these data types also have subtypes. For example, quantitative data is also divided in two parts, which is discrete and continuous. Discrete data is based on counting, and what defines it the best, it has finite amount of values. So, for example, if you have to, back to the example of rating, there is 10 possible outcomes. So you can rate 1 star out of 10, 2 stars, and others. Or you, yes, so everything that you count. And continuous data is measuring. So if you have to measure temperature, and let's say you have the most precise thermometer in the world, it shows you the tenth of the fraction of the temperature, and you will have in theory you can have an infinite amount of values, but they are fixed in a range. So for example, you can measure temperature between 0 and 100, and you have all the possibilities, but they are fixed in the given range. Again, discrete is counting, finite amount of values. Continuous, based on measuring, can take any value fixed in one range. And back to the qualitative data, it has also two options. It's nominal data, which are nominal from name. That's a data that gives a type, just a name to our data points. For example, if me and Adrian would be entry in some database, my name field would be Bogdan and Adrian's would be Adrian. We cannot do much with the data. For example, we cannot add this data points based on name. Doesn't make sense. But for example, if we would use other for example sex, we can divide then our data points into categories, which are male and female, but it's still a name. It's doesn't provide any numerical value. Other type is ordinal value, and this is also helps us to categorize data. But in this case, those categories would follow into natural order. For example, if you have to rate your experience, you can always you can say bad, good, and excellent. So there is clear order, between bad, good, and excellent. But you cannot take again any difference. You cannot subtract good from excellent and know exact numerical value of how much better it is. So that's what defines the ordinal data best. So let's look on the whole picture of data. So we have data, and in the end we have four categories: nominal, ordinal, discrete, and continuous. But that's a good all in theory. Let's look how it looks in real life. So here we have an example of data that can be used in real estate. And let's say we are looking for apartment to buy in Graz. So we have such fields as street name, amount of rooms, area, type, and price. And in real databases, there would be much more columns that would have different types, but we focus on this small, and let's look for a type for each column. So street name is of course nominal. Amount of room is discrete because there is a finite amount that are possible in one apartment. Area is continuous because you can have area of the house everywhere between, let's say the smallest apartment is 20 square meters and the biggest is 500 square meters, and you have everything in between. Type is ordinal because we have, let's say, luxury, standard, and economy type of the house, and we can say that luxury house is better than economy house, but we cannot subtract it and find the meaningful difference. And the price is also continuous type because, let's say, it goes from, in Graz, probably from 100,000 to few millions, and you get everything in between. But I have a question. So let's say we add a postal code to our data, and what type would be a postal code? Let's answer this in I believe it's our last quiz for a day.
Yes, that is correct. That's the last quiz in the day. And if you didn't manage to join to any of the quizzes, this is definitely one you should join today. So I put the link on the chat in case you never used AHA Slides, you came late. So you go on that link and then you can participate to the quiz. So I guess we can, let's bring up the quiz page. Let's get people joining up, and we can see people are now joining. So because the last quiz, maybe you close your phone, maybe, you were looking at some data science material on your phone and you have to go back to another slides. Now you can do that. Okay, we're going to start in 10 seconds, and this is the final quiz. So the question was what data type is the postal code? And that we're going to start in 3, 2, 1, now. And time's up. Let's see how well you have done for the final question. And most of you actually got it correct. It's nominal indeed. So some of you, there see me, some big chunk of you have chosen for discrete. Now,
Well,
what do you want?
that's a good trick from us too, because postal code looked like a number and discrete was for counting and numbers. But in this case, if you take two postal codes, you cannot sum them, you cannot subtract them. It's not representing amount of anything. You can. Its postal code is same as the name of the street. It represents same information. That's why you have to understand what data you are having. So if you get some database and you look on a column and you see numbers, the first thought, of course, that's probably some discrete or continuous value. But then you need to understand, oh, that's a postal code. It's same as the name of the street. A lot of different IDs in databases are also nominal types. You cannot add IDs. It doesn't make sense.
So don't worry if you got the answer incorrect now. In the next week, we will actually explore this a bit more deeper, and hopefully, after the second workshop, you will have a better understanding what data type is your data. So it's okay. You learned your lesson, and you will have more possibility in the future. So now, because we are done with the quizzes today, let's see the leaderboard. And congratulations, Max! You have our first place for today. So we will rank your points in the end for after all the workshops. But definitely, Max, congratulations!
Yeah, but you see, it's a very close call between first three places. It's a very, very small difference. So Lucas and Robert, you will have a chance till the end of our courses to get the first place. And everybody else, don't be discouraged. There is still a lot of opportunity to get to the first place.
Indeed. So I think that's a great job for you guys for now. It's anyone's game, but for now, let's learn more. So we talked about data and what are the different data types, but in data science, we also want to do solve problems, right? We want to automate our decisions. So let's assume we have these two columns from Bogdan's previous example. Here we have the amount of rooms and the price of those rooms, and this would be houses in Graz. And our goal is to, based on the amount of rooms, predict the price. So I would take all these data points and represent them in a graph. What we can see here is all those data points in our database. So we can see here the prices of one room. They're around like 52K. 2 rooms, 3 rooms, and 4 rooms. And here, unfortunately, this is in the way. Here would be written 5. And here we would have to predict the price of a house with 5 rooms in Graz. So how would you do this? Well, intuitively, it would make sense to fit a line. We would fit a line which goes through almost all of the points as close as possible. And based on that line, we can make a prediction for the fifth, for a house with 5 rooms. And in this case, we could predict, okay, the line ends around here. So we could say the house costs around 160,000 euros. However, let's change the problem a bit. Let's say I will give you only data for houses in Graz with 1 room. And I ask you again, predict me the price, or tell me what would be the price of a house with 5 rooms in Graz. Well, this is a bit more tricky, because how do you fit a line with here? You could fit it like this, you could fit it like that, even like this. There's no correct answer based on this. So the quantity and the quality of the data is very important if you want to predict stuff. So the question becomes, how much data do we actually need? And the answer might surprise you. It depends on the problem.
Very, very unsatisfactory answer.
Indeed. But over the time of, we hope over the workshops, you will get a better sense the data you might need. So for this, we will go for some examples and try to understand how much data on what type of data do we need to solve this problem. So one of the problems is, can we predict, based on the image, if it's a cat or a dog? So more precisely, given an image of a cat or a dog, we have to predict what is the likelihood, the percentage that this is a dog or a cat. So in this case, we have a photo of a dog, and the algorithm should spit 100% accuracy dog. Now, I think it predicted 99% dog because it's so cute and maybe looks like a cat. So maybe that's why the algorithm went wrong. But this is what the output should be. So the question becomes, how much data do we need? How many images of cats and dogs do we need? And based on empirical, I think, experiments over the 20 years, I would say, on image classification, we would need roughly 1,000 images per classes. So if I would want to make an algorithm which can predict a dog between a dog and a cat, then you will have a quite good model if you have 1,000 images for every class. Now, the quality of data is also important. If you only get images of golden retrievers, then if you put a dachshund, maybe it would misclassify it as a cat due to its size. So you really need a variety in your data, in those images, to work well. Okay. However, let's go a bit more ambitious. Let's say we want to make a self-driving car. Now, in essence, a self-driving car uses two kind of sensors mostly. First are cameras located around the car, where you can actually see the environment, and secondly, LiDAR, which helps the self-driving car to determine the distance between the objects. So, yeah, the video won't work for now. Yeah, we can skip that, unfortunately. But the question becomes, how much data do we need for a self-driving car? If today I want to make a self-driving car, how much data? Well, the answer, it's hard to answer, but based on some AI companies in San Francisco, more precisely Waymo, a self-driving company from there, they estimate you need 2,080 hours of data. That means you need to drive with the car 2,080 hours in variety of terrains and environments. For example, winter and day, summer and night, big variety of situations. So you can get a decent self-driving car. One more example would be language translation. I would assume everybody has used Google Translate at least once in their lifetime. So how much data would you need to make a language translator? Where in this case, the answer, it depends, but we can give an estimate. So if you want to get a good translator, it's also dependent on what algorithm you use, but also the data you have. And in this case, if you want to make an English to French translator, you would need 2 million sentences to actually translate well languages. Of course, these cannot be random sentences, as mentioned before. They should be a big variety of them. Finally, we will talk about this more often, but this is, I think, very essential. And if you didn't learn anything today, this is something you should definitely take home. And this is the data science pipeline. The data science pipeline represents all the jobs and duties we have the data scientists will have. Today, we have explored certain items of these pipelines. The first is the data. We have to acquire data, and we can see, based on the examples we found, we can have a rough estimate how much data we will need to gather. The second step is data wrangling, also called data cleaning, also called data manipulation. And in this step, we want to change the data in a way that our machine learning algorithm can use, but also remove stuff which don't make sense. So, for example, if I would like to predict the price of a house, and I would have a house which has -1 rooms, well, that should be removed because there's no such things as minus rooms in houses. So this topic we will actually explore next week more. Third is data exploration, and here we partially talked about like the data types and stuff like that. Really understanding your data. Do you have enough data? So we saw an
That's
example.
also here the statistics comes into play. For each column data, you find the statistical measurements like mean, median, standard deviation. It gives you very good understanding with what values you're working.
Indeed. And the fourth step, which I would say is the more interesting, but is only the smallest amount of work in data science projects, is modeling, and where you actually build a machine learning algorithm which predicts the thing you want to do, differentiating a cat from a dog, predicting the houses, whatever that might be. And finally, reporting. Most likely, you would have stakeholders where you have to report, where you present your results. Maybe you have to report for yourself to see how well your model is. There are a lot of reporting going on in the end to really validate what you've done and also to communicate it to other partners. So for that said, assignments. So before we go to the Q&A, we're going to talk about assignments. And you will receive through your email a quiz. And we will strongly recommend that you do it. Please use the email which you received the quiz from.
Yeah, and if you go to our stream not from our subscription, please go to our website and subscribe for a newsletter to receive assignments and information from new lessons.
Yes, indeed. So if you want to get the information when we're going to have the next course, this is the best resource to get information from us. So
it's our website. There is a lot of material you can already use. So if you go to the slides, you can find all the talks that machine learning grads hold, and maybe you will find something interesting for yourself.
Yes, indeed. So there are a lot of past talks, also from Bogdan and myself. So there are a lot of information if you want to go deeper in the topic. And the second assignment, after you put your fill the quiz, you need to have a Gmail account until next week. Why? We're gonna use a tool called Google Collaboratory, which we can actually program in. So we need all of you to have a Gmail account in order this to work. So you can, I would try, if you registered with it, it's fine. It doesn't have to be the same email which you registered to the quiz. We just need that you have a Gmail account. That's it.
Yeah. And it's never too late to register for this course. So it will be always open. You can tell your friends, tell your family, help you make the best time of staying in quarantine. Give people possibility to learn, so don't worry. You can always subscribe. The videos will be saved. You can watch it offline. Will we provide slides, Adrian?
Slides. It won't be the same as these ones because these are not something we can export. But yes, we can export some of the slides. It's not because we don't want to or share them. It's due to technical limitations of the system we're using. But yes, we will provide slides also.
So subscribe, leave like, subscribe, and hit the notification button.
Yes, indeed. So that's it. Let's go into the Q&A session. So we have a lot of questions. We will go through the top ones and down to we'll answer like 5-10 minutes. We can answer some questions. So please stay tuned. After the questions, we're gonna briefly talk about what we're gonna do next week. So so if you want to ask questions, please go to AHA Slides ML Grads. You can go there and ask a question. So ahaslides.com/mlgrads. Okay, so let's see the top voted questions. So deadline for the final project. So we will announce the project after the last week, and after that we will depending, it will be 1 to 2 weeks. We want to see, depending on how well the group performs during the weeks. This will also determine how big the project will be. So if you do guys well on the course, we will give a bigger project, but you can expect maximum, let's say, maybe 6 to 8 hours effort, something like that, for the project. Can we also ask questions in the Twitch tab? You can ask questions in the Twitch stream. However, we won't look all the time on the Twitch stream. If we see your question, then yes, we will answer it. But it's more a case of luck. So good that you asked the question here, because here this will guarantee you to get your question answered. Fernbedienung asked, a friend answered the question in time, but it said the time was over. So maybe he tried to. It's very hard to tell why that happened. Hopefully that happened only once. Maybe it was due to the ELSA slides, but don't forget there is a delay in the stream. So even though in the stream it says 0 seconds left, 10 seconds left, most likely the time was over. So please consider that in stream there might be 10 to 50 seconds delay depending on your network. Manfred asked, why is there a break now? Course was scheduled 5 to 7, so we have 25 minutes left. We're not sure where we said it was 5 to 7. We know we said this was to 5, but we're not sure if we mentioned it to 7. I'm not sure about that. I'm sorry it was longer than expected. We wanted really to everyone to get their questions answered. But also we wanted that everyone has the fair opportunity to answer the quizzes. Anonymous asked, I am not familiar with the cards, so I don't know. Example, how many are numbered, etc. So I think it refers
that's a taste of data scientist life. You get data that you're not familiar with, and so that happens. You get you get the questions that you're not familiar with. You get very little amount of time to prepare yourself. So
yes, indeed. So but in case with the playing cards, that's very unfortunate that that was hard for you. But hopefully with the vast variety of examples we gave, some of the probability examples were clearer for you. So thank you for asking this question, Anonymous. Arno asked, please explain the calculation of the dice combis. I guess the combination. I guess this was referring to the question which were answered on the chat. So yeah.
So thank you to the user Hilo Piglu. If I'm pronouncing it correctly, there is answer in a chat. So Adrian, you can check it and paste it again the message in the text. So everybody in the chat. Thank you to the user, to the viewer Hilo Piglu for answering to every.
Yes, if someone from the chat could copy his answer, that would be very great for us. That would help us out. So thank you.
We can read it. So there is.
Yeah, I'm trying to find it.
Yeah, I think so. There is a combination 1 and 6, 6 and 1, 2 and 5, 5 and 2, 3 and 4, 4 and 3, which makes 6 out of 36, which is 17%.
I actually have a video here. I have here an image which I can show you guys. Let me open it here. Here.
So
you can see here the dice combinations. Wait 1 second.
Yeah. Okay. I think we had the.
Just to show it. So here are the combinations. I think everybody now got it. Here are the possible dice combinations. Yeah, and based on that, you can calculate the probability. Okay, next question. So let's check that answer. Marked as read. Isabel asked,